Hi, so I'm going to be covering ANOVA technique. So we are going to be talking about the analysis of variance. This is the last topic that ma'am has taught. Right, so what is ANOVA? ANOVA stands for analysis of variance, and there are two types of ANOVA techniques. One is a one-way ANOVA, and the other one is a two-way ANOVA. But we will only be doing the one-way ANOVA because, yeah. So what is the basic? What is basically ANOVA technique, right? So when you want to determine whether or not there's a significant difference between the means of two or more independent groups. So this is very similar to your t-test two means statistics that we do. But with two t-tests, what happens is it becomes very difficult to do it for more than two independent groups. So when you have three groups or four groups or more than that, we do an ANOVA testing. Right. So a one way is basically that it is used to determine how one factor will affect the response of another factor. For an example, you can take how a studying technique will affect your exam score. So out here, your factor becomes your studying technique, and your response variable becomes your exam score. So this is basically what a one-way ANOVA is. Okay. So yeah. So these are the three assumptions that we do. So normal distribution, all populations have the same variance, and the samples are randomly selected and are independent of one another. Now, where do we use this is the main thing in real life, right? So basically, if imagine, so we mainly use it for like pharmaceutical companies use this a lot, but we also use it for advertisement. So for advertisement, this is how it's used. So grocery chains wants to know if three different advertisements affect the mean sales differently. So basically, what they are trying to do is they take the each type of advertisements, and they run this advertisements in 10 different stores for each one of them. So total you have 30 stores, and for each of the 10 stores you have different advertisements, and at the end of a month they determine the sales, the revenue that has been generated. And so basically at the end of this study, what they're trying to find is that are these advertisements affecting your sales or not, or are these advertisements different from one another? So right, so supposing if the sales of all of these three groups is the same, that means your advertisements are pretty similar and it's not affecting your sales as much. But if the mean is not the same for all three of them, then it means that one advertisement is doing better than the other two. But the limitation of ANOVA comes out here, wherein you can't figure out which advertisement is doing better than the rest. So that is one limitation of ANOVA testing. So now I'm going to solve a sum. So the sum is that the NTSB board wants to examine the safety of three different types of cars. So basically what they do is they're having a crash test, and they want to see that how much the pressure is being applied to the driver's head during the crash test for these three different types of cars. So this is the data. So these are the pressure values that we've given, the impact that is being caused to the driver's head. This is the mean for each of the data points given, and this is the standard deviation. So now the first step is to state the null and alternative hypothesis. So out here in ANOVA testing, always remember that the null hypothesis is always that the population means are equal. By default, that is your null hypothesis. And your alternative hypothesis will always be that at least one of the mean is different from the other two. So that is always going to be your null and your alternative hypothesis. So basically the H naught means that pressure is equal across the three different types of cars. So no matter what type of car it is, if it's a sedan or an SUV, pressure same hi aayega. And your alternative hypothesis is that probably if you're sitting in a compact car, then there'll be more pressure as compared to an SUV car. So one mean pressure is different from the other two, or some Right. So how do you solve this sum? So the first step is to find the grand mean. So your grand mean is basically when you find the mean of these three means, the means of the data independent groups. And when you find the mean of the independent group, that is your grand mean. The second step is to find your SST, which is treatment sum of squares. So now there are two types of variations that come in groups. The first one is between the data and the other one is within the data. So when you're trying to find between the data variation, you use your SST. So your SST formula is this. Out here, your N stands for the number of rows. So as we know, the number of rows is 3 for this, 3 for this, and 3 for this. So out here, all of them is 3, and this is the mean of the independent groups minus the grand mean, and you square it and you add and you find this as your answer. So this is your SST. Then you find your mean square treatment, which is MSST. So this is basically you dividing your SST by your by C minus 1. So out here, C is columns in the data table. So, and you get this answer. So basically, mean square treatment is again, you're trying to find the average variation between the groups. Okay. Now the next step is to find, so between different groups, now within the group, also there are sort of errors that come up while doing a statistic. So you have to calculate that also. So for that, we have an error sum of squares, which is SSE. So this is variation in data from each individual treatment. So this is within variation, right? So the formula is this. So summation xij minus xj mean. So this is a pretty lengthy one. So I've not completed it, but yeah, this is quite lengthy to do. Then you find your mean square error, your MSSSE. So this is average within variation. That is, you divide your SSE by N minus C. So your N is total number of observations. So out here we have 9 total observations, 3 plus 3 plus 3. So 9 minus C. C is your column. So 9 minus 3. And this is the value that you get. Now, coming to the main part, you have to find your F statistics, F distribution or F statistics or test statistic, whatever you want to call it. Basically your F calculated, right? So that is your MSST upon MSSE. So that is basically you're dividing your between variation by your within variation. So it is this value divided by this value, and that you get it as 25.17. Next comes your F critical value. So this is something you get from the statistic table. So it is, how do you find the critical value is F df1 comma df2. So your df1 is C minus 1, that is number of columns minus 1, that is 2, and df2 is N minus C. So your N is total number of data points minus C. C is your number of columns. So that is 6. So you get F 2 comma 6 with your alpha given as 0.05. So if you see the statistics table, you need to find F 2 comma 6. So 2 comma 6 is basically 5.14. So your F 2 comma 6, you got it as 5.14. Now comes to the decision. So as we know, the F calculated, the F statistic for us is greater than our F critical. So that is why we reject the null hypothesis. Right. So whenever your F statistics will be greater than your F critical, you will be rejecting the null hypothesis. Right. So basically, when you're rejecting the null hypothesis, what does it mean? That your mean is not equal for all the your mean is not equal, right? So what is the interpretation? What is the final answer of this is that your mean head pressure is not equal for the compact, mid-size and full-size cars. So depending on what kind of car you sit, you will get a different kind of pressure impact on your head. So this is what the final conclusion of it all was. Yep. Okay, thanks.